So these are the three objectives. One is to find the antiderivative of a rational expression. Two is to find the definite integral of a trig function. So remember yesterday we started with definite integrals, where you have a number and then you substitute the number. So today we'll try doing that for trig functions. And then the last one is to find the average value. Okay? Can I move on? Alright. So the first one, what is do you remember what a rational function looks like? What is the rational expression? Sorry? 2x, okay, but it's rational. When I say rational, what? 3x parentheses x plus 1, then what? Rational. Rational means louder. It's fraction, correct. It's a fraction. So think of it, remember we did rational expression, asymptotes, all that. That's rational expression. Something like x plus 1 over 5 plus 2, 5 plus x, something like that. But now, all we'll be looking for is expressions like this. Say, x squared plus x divided by x. You see this? I say, is this a rational expression? It is like a fraction, you get it? We are looking at functions only with one denominator. One denominator, one expression. So, just like this, you have only an x or 3x or 2x. You get it? This is the type of problem we are going to solve. So, when you have such a function, the first step is going to be, you're going to split. Step 1 is split the fraction. So, what am I going to do? In the integral. So, do you see I can split it into x squared over x. X squared over x, you see that? Plus 1, x over x, that's 1, okay? Do you understand what I did? So when you have one denominator, you're going to do x squared over x plus x over x. You understand? That's the first step. Now, I cannot, remember, if I have an expression like this, I cannot split it. The way I can split it is x squared over x plus 1, x minus 1 plus x over x minus 1. So the way you split it is with that. Okay? Do you understand? So now, the second step is to simplify. Of course, you could do it here itself. Split the fraction and simplify. So what will happen when you simplify this? What will you get? X, correct. X squared over x will give you x plus x over x will give you, that's it. So now you see you have an expression of the form that you know. You can integrate. Yes? Where? That's a good, okay, that's good. That's a good option also. Yeah, he gave a very good point. He said, why can't I just factor out the x and write it as x plus 1? Very good. You can do that and then cancel it out. Good, you can do that as well. Good suggestion. You can do that. Alright? If you thought about it, you are not wrong. Like, you're absolutely correct. You can do that. Alright? So now, so here, now all that you do, step 2 is to find the antiderivative. Step 2, find the antiderivative or find the integral. Both are the same, okay? So what will you get when you integrate this? Plus Yes, 1x, so which is just x plus c. What happened, Namdi? You get it, guys? Yes. So this is the antiderivative of the whole function. So the basic thing is, if you know you can factor it out, go ahead. If not, split it into two different expressions. You understand this? Okay, we'll try one more in this method, and then we move on to the trig ones. So one more problem based on this one. So what if I have x? So problem number 2 is x to the 5th plus 2x squared minus 1 divided by x to the 4th here. And over time, you guys can do it in your mind. But Patrick, do you see, can I factor anything out? No. So yours is good when you have something to factor. If not, this is how. Okay. So I'll give you a minute. Try it out first with your partners and see if you're able to get it. It is actually more than the book I cherish. So this one, for this, I'm using two different it's 4.1. Teaching them now. Alright, it is a minute. Okay. Alright, so how do we do? Yes, Nandi?
You cancel the x before the and cancel x at the first of the x.
Correct. So you can do it out right in your mind, you don't have to split it. I know I mentioned to you, you got to split it, but you don't have to do every single time. So x to the 5th over x to the 4th will give you. So I'll write it anyway, so you can see it. You see that? Plus 2x squared over x to the 4th minus 1 over x to the 4th dx. Okay? But if you have to do it in your mind, it could directly be, you can say x to the 5th over x to the 4th is going to give you x. You see that? Now here, what will happen to this expression? 2 over x squared plus 2 over x squared minus, here nothing else can be done about it, right? 1 over x to the 4th. Is this that clear to you? So what did I do from here to here? We just split the integral. Alright? Not the integral, you split the denominators. And then over here, I'm just rewriting it by simplifying. Now we are trying to find the antiderivative, but look at these expressions. Yesterday, when we looked at terms in the denominator, what do? You bring it up to the top. Remember, it's because you don't know what x to the 1 over x to the n is. You have to bring it up. So you rewrite it as x plus 2 times x to the negative 2. You remember doing this yesterday? Minus, what does this become? X to the negative 4. Now, good, it is not ln here. It is because it's only 1 over x is ln. Alright? Good, but I'm glad you mentioned that. Okay? Now get the antiderivative. So what did I do here? I brought the exponent, bring the exponent to the numerator. Oh my God. Alright, so here what will be the antiderivative? X squared over 2 plus 2 times x to the, correct, x to the negative 1 over, see, x to the negative 1 over negative 1, remember? See that? Because it will be negative 2 plus 1 over negative 2 plus 1, it will be negative. Minus, what will this be? Negative 4 minus 1 dear. Oh, sorry, negative. Oh, hold on. And plus 1, correct. Plus 1. So here, plus 1 will give you negative 3 over negative 3, correct. Got that? Correct. So now we'll rewrite it. So the integral is over. See that? So all you're left with is x squared over 2, then bring the minus sign to the number. So negative 2, x to the negative 1, right? So we don't leave it with negative exponents. What do? Correct. Bring it down over x. So minus and a minus is going to give you plus. Okay? Plus, this will be x to the negative third will come down and you have a 3 already down. So 1 over 3x cubed. Are you following? No? Okay, which part is confusing? This one? Okay, the third one over here, okay, what did I do? The minus and the minus will give me plus. So it's plus 1/3. You understand? Now, I have x to the negative 3. Negative 3 in the numerator has to be brought down to the denominator to become x to the third. 1 over 3, because when you are integrating this, x to the negative 4 plus 1 over negative 4 plus 1. So negative 4 plus 1. So, okay. You get that? It was like